Hello, my name is Krulal. In this video, I'm going to talk about what cert-manager is, how it works. We're going to talk about a little bit about the certificate authority issuers, and then we're going to talk about ACME server. ACME server allows you to have your certificate signed so that you could use them over internet. And then we're going to talk about HTTP 0 challenge and DNS 01 challenge. And after that, we're going to have a tutorial, and I'm going to show you how you set up cert-manager and how you retrieve certificates. So first thing first, so what is a cert-manager? So cert-manager is essentially when you deploy it on any Kubernetes cluster, it makes your certificate management a lot easier. It creates TLS certificates after having signed from certified authority. It renews those certificates when they're about to be expired. It helps the signed certificate from various sources like Let's Encrypt, HashiCorp Vault, or any sort of a custom CA. So how does it work? So imagine you in a Kubernetes environment, you have a Kubernetes cluster, you're gonna install cert-manager, and then the first thing after installing cert-manager, you're gonna install another Kubernetes component, which would be issuer. It's gonna contain information about your certified authority issuer. So those issuers could be like HashiCorp, custom CA, VAS, or Let's Encrypt, which is ACME server. So this issuer contains information about what cert-manager should talk to have the certificate signed whenever there is a request to have a certificate signed. So that is a little different. So after you have this sitting in your environment, then you try to create a certificate. You'll be like, hey, I want to create the certificate. Cert-manager is monitoring it. When you requesting to have certificate signed, you include the information about the issuer that you want to use. You also include the information about what sort of a key I want to generate once the certificate's been signed. So that's what something cert-manager is going to do. We're going to see that in action when I'm going to demonstrate that later in the video. So you create a certificate resource, and cert-manager is monitoring it checks, okay, this is the issuer it's trying to talk to. It goes to that particular issuer, have that certificate signed, come back, and it creates the secret. It's cert-manager that's creating the secret, and then you can use that secret for your apps, and then your apps could be accessed, whatever the domain, whatever that certificate has been issued for, and using that particular certificate. So I want to point out that the SSL certificates could be internal or public. So typically we use HashiCorp, custom CA, and VAS to have certificates signed internally. And big corporations would have some sort of a CA root, and that would issue the certificates for any sort of a internal communication or the devices that you're using in your environment. So that's where those HashiCorp, custom CA, and VAS could come into play to have that internal SSL certificate assignment. So next, we're going to talk about ACME server that implements ACME protocol for automating issuance of SSL certificates. So it allows tools like cert-managers to request, renew, even revoke the certificates. Of course, you gotta have some sort of authorization in place, but as long as you provide the valid domain, which it's gonna verify, we're gonna talk about it shortly. So it verified the domains with using particular challenges, cert-managers coming to you, hey, I want a certificate for google.ca. So it's gonna make sure that you own that domain. So if you can't validate or that you own that domain, it's not going to give you the certificate. Examples for this, that the services, the certified authorities that use ACME servers is Let's Encrypt. It's widely used. It's free. You can get the certificate from Let's Encrypt as long as you provide the valid domain. And there's another option like Zero SSL and Google CA. Typically used for public SSL certificate after domain verification, like HTTP 0 challenge or DNS 0 challenge. So let's talk about those challenges. So we have HTTP 0 challenge. So so you configure your issuer on your cluster, specifying that it's gonna have HTTP 0 challenge, and then whenever your certificate is sending the request to ACME server, you have specified in your issuer that it's gonna use HTTP 0 challenge. So One thing I want to point out that whenever you're using HTTP zero challenge, you can have a wildcard certificate. So it's gonna be a particular domain. So the way it works, so similarly, you have Kubernetes cluster. You set up cert-manager, you define issuer, and it gonna contains the information about ACME server. So in our case, it could be let's encrypt. So and then you try to create a certificate and be like, okay, the cert manager is monitoring. It's like, okay, the clients or the app, you need to create a certificate. It has the information about the issuer, which is let's encrypt. Cert manager goes to let's encrypt, and it comes back and it provides a token and URL path. So what cert manager does in return, that it creates the ACME part, and ACME parts would have expose your token at a particular path that Let's Encrypt could verify over the internet. So Let's Encrypt gonna be like, okay, this is the domain I'm trying to issue the certificate to. I'm gonna try to reach out to this domain. I'm gonna see that the token I just provided, it's available on this particular link, and the token is there. I think I may have missed it, but whenever you're using this type of challenge, you just gotta make sure that you already set up a record for your domain wherever you're managing your domain. So if you don't have that in place, Let's Encrypt will know where to go to, and the domain isn't getting resolved to any IP address. So just make sure that you create the A record before you go into all this HTTP 00 challenge requests. So that's how it basically works. So you expose a particular link and URL at public location or public path, which Let's Encrypt verified. It comes from like a different locations. It would send a request from like a various location in the world to just make sure that it's validated. And yeah, once it's verified, it ensures that, okay, you own this domain. It gives you back the certificate. Signed certificate. So when it comes to DNS zero challenge, so you prove your ownership by putting a specific values in TXT record for your domain. So what you do, you basically provide API credentials, which essentially add those values, and the cert manager would have permissions like that. So the way it works, you have a Kubernetes cluster, you set up a cert manager, you define CA issuer, and say let's encrypt. So you try to create a certificate, and cert manager goes to let's encrypt. It comes back with a token. And what cert manager is doing now, you have given the API permissions to cert manager. It's going to go to like wherever you're managing your domain, something like Route 53 or GoDaddy, wherever you are, you provide the API credentials to for cert managers to access that, and it would temporarily add the TXT values that, again, Let's Encrypt gonna verify using lookups, saying that, okay, yeah, this domain has these TXT values that I ask it to do that. Okay, perfect. So it tells me that this person who's requesting the token or having the certificate signed for this particular domain owns this domain because it could provide the TXT values. Now let's do the tutorial. So for this tutorial, within my DevOps Avenue repository, I've created a new directory, kind cert manager, and includes the README. Whatever I'm doing in the tutorial, everything is in here. So before we start, prerequisite is that you're just gonna make sure that you have AWS CLI and Terraform installed and configured. Terraform should be communicating with your CLI or AWS resources to create any sort of resources. And also keep in mind that the code that I'm going to use shortly with Terraform, it specifies a key pair. So you're going to have some sort of a key pair available. So if you're going to just copy the whole content sitting in here, I'm just going to make sure that you update the key. And the last thing, you're going to have it that the valid domain. So I have this domain, I own this domain. So we're going to create a subdomain, which is going to translate it to the app that we're going to expose using Kubernetes. So this is the domain I'm going to be exposing, blog.gorlal.com. So if I go there, it's not resolving to anything because there's no record in my DNS, so it's not getting forward anywhere. So let's get started. So the first thing we're gonna do, I'm gonna go to my terminal. So I already have that repo cloned. So I'm gonna go to kind cert-manager, the directory, and here we have a Terraform directory. So the Terraform directory has the code that's gonna create EC2 instance in the security group. We're gonna keep the simple things. We're not gonna make it fancy. So let's just go to that directory. So there's a Terraform code. Let's quickly revisit this. So this Terraform's code is relatively simple. You have a provider and then you have variables defined for your EC2 instance. And in the second file, we are creating the EC2 instance. I'm getting the AMI ID from using data resource. And then I'm creating a security group. The security group is allowing incoming traffic from port 80 and port 443. Also the SSH access and the Ingress, everything is allowed. And there is internal communication is also allowed. So the security group is going to get attached to the EC2 instance. And then the last file that we have is the output. So I'm just outputting the public IP address so that I could use that to access my node. So I'm going to do Terraform init to just kind of initialize my code. After doing that, I could run Terraform Planter just to verify that there's nothing wrong with my code, just kind of spot any errors. I'm just creating two resources. It's nothing complicated in this resource. So clear this window and I'm gonna do Terraform apply. Confirm that and it'll create, like I said, EC2 instance and a security group for you. This one shouldn't take long. It's a relatively quick process. Okay, so this is the public IP that I can use to connect to it. So the first thing I gotta do, I gotta specify the key that I have that I'm using for this to access this node. Okay, so our infrastructure is kind of set up. So for this demo, what we're doing, I'm gonna set up a kind Kubernetes, like, Kubernetes in Docker. So to do that, once you connect to your EC2 instance, we're gonna install Docker. So first, I'll run this command. It's going to use yum to install Docker, and then I'm going to start the service. And then the last command, what it's doing that is adding permissions so that our current user logged in are part of the Docker group so that they could run Docker commands. Okay, so Docker is installed. So if I run Docker PS now, it would say, I typed it wrong. It would say I don't have permissions, but I've assigned my user to the Docker group, but I have to kind of quickly log out and log back in for the changes to take in effect. So I'm just going to exit and reconnect. And if I run Docker PS now, I don't have anything running, but at least I'm not getting any permission errors. So next thing we're going to do, we're going to set up a kind cluster. So I have this script sitting in this directory. So basically what it's doing that is installing kind for us. It's going to download the kind. First is checking that the latest kind version, and then it's gonna download kind and install it for us. Then I'm installing kubectl. I don't want to use kind to interact with the resources in the kind cluster, so I want to use kubectl. That's what I'm familiarized with. So so I'm installing that, and then we are creating the kind cluster. And then there is a configuration that you may find it, you're not familiar with that. So what's happening is that the kind works in Docker. So we got to make sure that wherever this kind is running in whatever container, it is mapping to the host port. So if I'm trying to reach kind server over the internet or connect to its API and everything like that, I'm able to do that. So I'm just mapping kind container ports to my host ports. And then at last, I'm just enabling kubectl completion. If you want to remove that before you run it, you can do that, but it's not going to do any harm. Definitely like it. So let's download this script on my machine on the node that we're working on. So then just run it. So first thing we got to do, we got to change the permission so that it's executable, and then run the script. Okay, so script is completed. It has installed kind. So if I do kubectl get nodes, I should have a kind node listed. Yeah, so there's a one node. It's running under Docker. So if I run docker ps, it would say me that, oh, it's running kind. So yeah, so our cluster is set up, single node cluster is set up. So what I'm going to do now is then I'm going to download Nginx controller so that I can expose my website or the app that I'm going to run it to internet. So let's download. So I'm using this official source where that's download the controller. So I have this command from the official source, and I'm just going to download that, deploy the YAML file. So once it's downloaded, so since we're running in kind, we're gonna make sure that the Nginx controller ports are also mapped to the host port. So if I'm trying to access Nginx controller over a particular port from the host IP, it gets mapped to the controller parts. So you just gotta go to edit the file that we just downloaded, and in the deployment and for the containers, add host ports. So let's quickly do that. So once the change has been made, the ports are mapping correctly to Nginx controller, we're gonna deploy our controller. Okay, so once it's deployed, I can check its status if I just run kubectl pod. They are still being created. So some of them will stay in a completed state, the admission and the patch one. We're just concerned about the controller. So once it's ready, we should be able to access Nginx controller over the public IP of our node. So if I don't remember what was IP of my node. So it's this guy. I'm gonna grab this one, reconnect to my node so that, and if I go to this IP address, it's going to Nginx, and there's nothing behind Nginx controller, so it's not finding anything, but at least I know that my Nginx controller is reachable over the port 80 or 443. If I try to go to 443, it's gonna go back to like essentially saying that I don't have a secure connection. So now, next thing we're gonna do, we're gonna deploy the app. So I do have a web app available sitting in the this repository. So I have a deployment that I'm creating. So deployment's gonna have 2 replicas, and it's referencing the image from my Docker repository, Docker hub, and I also have the resources specified. And then I'm creating the service, and it's using the node port. And then at the below I have Ingress. So the Ingress is using the host name, and if someone's trying to reach to this particular host, and it's gonna forward the traffic to the service that we're creating above. So let's go back to README and download this manifest. Clear this window, and next, so create this one real quick. Perfect. So now I'll just do kubectl get part just to make sure that they are created or being created. They are in the creation process, still being created. We'll just wait for a few seconds here. They are being created in a default namespace. So yeah, there they are. So they've been created and should be exposed through this particular domain. So now, right now, if I go try to access my domain, it's not gonna work because my DNS isn't resolving to anything. So what we're gonna do, we're gonna add our host IP, and as in a domain, I'm gonna add as a record. So the domain we're trying to access is blog2. And the value for a record is going to be our public IP address of the node where our Nginx controller and kind is running. So we're going to create this record. To verify that the changes take effect, you could just run SSL lookup. And if it's, okay, what did I do wrong? Something isn't working. Oh, sorry, oh God. It's a rookie mistake. NS lookup and type the domain name. So it is resolving. So if I try to go to my particular domain and refresh this one, I should get something. Okay. Okay. So it's 142, just that's the one. It's blog.2grlol.com. Okay. Access multiple times, and sometimes we may have to wait a little longer for it to get. Oh, it is working, so I think it might be in the cache on my previous browser. So here it is. So my app is working. So if I go to home page, it's gonna, just displaying welcome to DevOps Avenues. And then I truly actually says that I hope you're having fun, and I truly hope that you're having fun learning Kubernetes. And then there's another page about page has like a couple of links, one to YouTube, another one is to the blog. So if I go to my certificate options here and view certificate details, right now there's a certificate name called fake certificate. So this is no certificates. This is essentially a placeholder for certificates Kubernetes assigned to Nginx apps. So we gotta assign some certificates to our app so that it's trusted. So we're gonna start with assigning self-signed certificates. So for that, the cert-manager doesn't have to go to any certified authorities. It's going to use the private key of the certificate when is requesting to have it signed. I have prepared all the files to create different issuers and different certificates. So we're going to use that. Before we get to that, we're going to install cert-manager. So let's do that. So I'm downloading it from the official source. If the version get updated, just visit the cert-manager official website and you'll be able to retrieve the latest YAML file. So there's a Helm option available too. You could install using Helm if you like to. I'll leave the link below in the description for you guys to check it out. So let's go quickly to our terminal and install cert-manager. Okay, so if I do kubectl get pods in a particular namespace, they are in creation state. Oh, there we go. So they are in running now. So next thing we're gonna do that now the files that I was talking about, they are sitting in the certificate manager directory in this repo. So the first, the one that we're gonna use, self-signed issuer, is that containing the information about self-signed. So for self-signed, whatever the issuer you are using, and whenever you defining issuer, the configuration is going to vary under spec. And forgive me if I haven't mentioned, but there's going to be two types of issuers. So it's going to be one cluster issuer, and then it's going to be regular issuers. So regular issuers are just kind of namespace scoped, and when you use cluster issuers, you could issue certificates in all the namespaces within your cluster. And then I'm defining the name and then defining the specs that it's going to be self-signed. And then there's a certificate YAML, which is essentially telling it's the kind is going to be certificate, how I want to name it, and is it going to be CA true. When I'm setting it as CA true, it basically means that the certificates that I'm going to issue could be reassigned or by the middle certificate authority if needed to. And I'm telling it that it's going to be DNS name. I'm specifying it's going to be what domain is it for, and I'm specifying the secret key. I mentioned earlier that in the certificate resource, when you're trying to create certificate object, you specify the key that the cert manager should create as soon as you have the certificate signed. And since it's a self-signed, we're specifying the algorithm that we want to use for and the private key that we're going to use, and it's telling us to what issuer to reference to. So the issuer that we just looked at before, so it's telling that it's the kindest issuer, and this is the issuer I want to use whenever you're signing this certificate. And then we're adding additional details for our certificate. Let's go to our terminal, and I'm going to go back to the README. The README is going to allow me to download all this issuer and certificate files. So let's quickly get to that point. Where is it? So here are like all the 6 files. We'll talk about other 4s as we get there. Okay, so all those files should be downloaded if I just do ls real quick. So there they are. So this one is where we're going to use it for ACME, certificate for staging, and there is a self-signed one too. So let's create the self-signed issuer first, and then we will look into ACME or having publicly validated signed SSL certificates. So first we'll create self-signed. And after signing the issuer, I could describe it real quick if I like to. Just run kubectl describe cluster issuer and the name of the issuer that you are using. And it'll tell you that it is ready and the status is true, and you should be able to use it. So now the next thing we're gonna do, we're gonna create the certificate, self-signed certificate. Just run kubectl create a self-signed cert. And this is the file again, downloaded and the step above. Oops, not what I wanted. The command should be kubectl create self-signed cert. If I run this one and it's gonna create the certificate for me, I can view the status of my certificate if I like to. All I have to do is just go to describe that certificate, and that's something that you will refer to if you're having some sort of a trouble. So it's saying that the certificate's been issued. It's kind of gives you the events, give you a bit of an overview how the process starts, saying that issuing certificate as secret doesn't exist, and it's creating the new private key in the particular directory. The cert-manager is doing that, and then it's also creating this resource, and then it's telling you that the certificate has been issued. So it would have created a secret. So if I do kubectl get secrets, it has created the secrets. If the type is suggesting that Kubernetes IOTLS, that means the certificate has been signed. So now we're gonna assign this certificate to our app. So one thing I could do, I could add the manifest of our Nginx file that we used and go to Ingress. And there is a TLS options that I've commented. You can remove this one, remove the comment, and it's just Ingress is telling that, hey, I want to use this particular certificate, and it's telling you that who's the certificate is for. So this certificate, and actually let's just quickly modify. It should be saying sec update this file. If I do kubectl apply this file, and it has configured my Nginx. If I want to view what's happening with my Nginx resources, I could view the logs of my Nginx controller and to see the status of it. Before I even go to website, I would know that what is happening. So this is the controller we want to get the logs for. So let's quickly go back to the command that we were trying to run before. If I go in here, it's gonna have a detailed summary about what this controller is doing, and it's saying that it's error getting this local certificate, and then it's saying successfully validated, and it has added, and then it's saying that, oh, it has added this certificate. Let me quickly make sure that this is the name of the certificate that cert-manager created. Okay, so yeah, it has added to our Nginx app. So if I go to portal, like my website now, and advance, proceed here, and go into my certification details, yeah, there you go. It's using self-signed certificates just issued like maybe a few minutes ago, and this is the organization name we specified in our certificate when we were creating it, and that's what it has it. So let me quickly show you guys where I specified that organization name. So if I go to my self-signed cert, and this is the subject, I specify that this is the organization it should have whenever the certificate gets signed, and that's what it is assigned to my certificate. So yeah, so our self-signing certificate is working, our cert-manager is working. It is monitoring the certificate creation and creating the secret, and then Nginx controller assigning those secrets to our Nginx apps just fine. So the next thing we're gonna do, now we're gonna use ACME server. So when it comes to ACME server, have our SSL certificate signed, which would be trusted by all the public browsers and everything like that. ACME offers you private server too, just to point out. So like, but we're gonna use public server. The first thing we will do, we will use the staging server. So the staging server, the certificate that get assigned is not validated, but it verifies that your communication with the ACME server is working just fine. If I go to the files that we're gonna use for the staging, I'll go to staging issuer. It has, again, we use the cluster issuer, we're naming it, and the specs gonna vary. As I mentioned before, the specs for any issuer varies based on the certified authority that you're gonna use. So for ACME, you start with the ACME key, and then you specify the server name, and then you provide the email address. So you gotta provide the email address so that ACME server would create account for you associated with the email, and then you provide the key that you wanna use. And when it comes to solver, we are using HTTP, and we're telling it that it's gonna be Ingress, and where is that app, is what class that we're using to whenever the HTTP solver is gonna work. So it's gonna create the resources behind this Ingress, which is using Nginx class. So this is the issuer. When it comes to certificate, let's go to the staging certificate. We're specifying that this is kind certificate, providing the name, and then giving the DNS name. And then we're providing the issuer information, that what issuer we're gonna use so that we can communicate with ACME. And we're specifying the secret that we want cert-manager to create once the certificate has been signed. So let's create these ones. So I go back to my README and I'll copy this command. The file's been downloaded and the steps above. So I'm gonna create the issuer. Okay, so issuer has been created, and I'm going back to, now we're gonna create certificate object. Going here, okay, perfect. So now the certificate has been created, and if I describe my certificate, and view its status, you would see that it has requested it, and it hasn't been, the certificate hasn't been signed yet, but for the staging it's relatively quick, and it should get back to you within like in 20 seconds or 30 seconds after doing the validation, verifying the domain name, and it would just say the certificate has been successfully issued. There we go. So it took about like 25 seconds to retrieve the certificate from ACME. Again, this is for staging. So now what we're gonna do, we're gonna assign this secret that we got, which has our certificate and the private key sitting to our Nginx app. So I will edit my Ingress app, and go to TLS. Okay, so what's the name of my secret? So I'm gonna quickly go back to my files here, just gonna grab the name of the secret. So it's DA ACME HTTP staging. So let's come back here and add the secret name, save it. It would update my Ingress. So if I could view the logs of my controller to see if the changes taken effect or not, it'll tell you that the sync is scheduled and it is in sync now. So, okay, so if I go to my browser now, I should have a different certificate than what I had before. So if I go in here, it hasn't been refreshed yet, so I'll go to maybe different, wait for a browser, or maybe go into private mode and just to see if that would work. Okay, so let's just advance here, click on it, and I go to my certificate details, and there it is. So now it's the staging certificates coming from Let's Encrypt, and it has a common name, and it's just, you know, telling you that this kind of confirms that our communication cert-manager can communicate with cert-manager, sorry, Let's Encrypt just fine. So let's assign the certificate, the real certificate that would ensure that our communication is secured over the internet. Gonna go back to there's more files for prod. So there's the issuer for ACME HTTP prod issuer. This one is using a different server, and you specify the email address and then the key that you want to use. And again, the solver we're using HTTP 01. And similarly, we have a certificate. It's similar to for the staging. It's just going to specify the different key name, the secret we want to use, and the issuer that we are using too. Okay, so issuer has been created. The next thing we're going to do, we're going to create the certificate. Okay, perfect. So certificate has been created. The next thing we're gonna do, we gotta monitor first that if our certificate's been issued, and then once it's been issued, the cert manager would create the key, and we're gonna update the secret for our app to refer to the issued certificate. So this one does take a little longer. Actually, not really. I think the communication was perfectly working just fine. So it has issued the certificate to and created the key. Now we're gonna do, we gotta update the Ingress app. Let me quickly get to that and update the TLS certificate. So this one, the name is pretty similar to what we used before. I'm gonna remove from staging to prod and save my configs and wait for I don't really have to wait, actually. I should just get it. Oh, there we go. So if I accessing my website now, it is saying the connection is secure and everything. And if I go to connection secure and certificate is valid, or trying to get it, it would say that it is issued to blog.gorilla.com, and the organization where the certificate has been issued from is Let's Encrypt, and the common name. Yeah, so there it is. So now we have our app. Our app has a TLS certificate issued, which is trusted by all the browsers. A couple of things I want to point out before I wrap up this video, that there are the commands included in each section whenever we're creating the certificates in the README of this in the repo. So you could just run the different commands to describe the certificate. Even you could describe the secrets. When I mentioned before, if I describe the secrets, I would have information that, okay, it has a TLS certificate and TLS key that gonna get assigned to my app. And if I just do kubectl get secrets, if the type is showing that Kubernetes IO TLS, that means that it has SSL certificate and it's been issued by cert-manager. So that kind of bit of you don't even have to describe it. If you're just doing the get and it's saying that, you would know that the certificate has been issued. Actually, the key only get created, secret key only get created once the certificate has been issued. So yeah, so that's it. That's what I wanted to show you guys and demonstrate, and I hope that you have a bit of understanding about how Cert Manager works and how you could get a free certificate from Let's Encrypt using Cert Manager within your Kubernetes environment for the apps that you're exposing to internet. Thanks for watching. I hope you enjoyed it. If you did, please consider subscribing, liking the video. If you find it something objectionary or you have some sort of a feedback, please leave a comment below and I'll get back to you guys. Thanks again.